12.4 is the last section of this very, very short unit of Unit 12, which has everything to do with circles, if you didn't notice. 12.1, 12.2, 12.3, how do you find the angles? Well, the last section has nothing to do, well, it has one small thing to do with some central angles. And as a matter of fact, the majority of this stuff is going to be based off of a 5th grade standard, which talks about the area of a circle and the circumference of a circle. So depending on how good your 5th grade or 6th grade teacher was, will depend on how much you already know. Maybe you already know the area of a circle, of a complete circle, is pi r squared. And maybe you already know that r stands for radius and d stands for diameter. Radius is from the center to the outside. That's a radius, that's a radius. Diameter means from the outside through the center to the other side. A diameter is the full distance. So there's two formulas for circumference, meaning the distance along the outside. I think of circumference as the crust of the pizza, whereas I think of the area as the pepperoni and the cheese in the middle. Think of it as the shaded area. Well, this is your 5th and 6th grade standard. Your high school standard is really going to be on these two things right here: arc length and sector area. If you know these two things, then you know what's in section 4. So before I get to that, don't forget we're still using arcs. If that arc, that central angle, tells you how many degrees it is, you're going to need to know that. And then you're going to put that out of 360 because that's the percentage of the whole circle we're using. Sometimes you're going to be given like this is 75 degrees. Well, how much is that of the whole circle? It's 75 out of 360, which is why we have these two formulas. The two formulas are the percentage times the circumference, or the percentage times the circumference when there's a diameter. That's the hardest part. Arc length is the length of the distance along the outside. Imagine there being part of a circle, and what you're finding is that distance along the outside. That's why I call it the crust, because it looks like a piece of pizza when you're looking for that distance. How much crust is there? That's what this is. Whereas sector area is how much pizza toppings and how much cheese is there. We're finding when it's shaded, we're finding this time. Notice that they only give you an r squared, not a d, because you have to use the radius for the sector area. The very last thing that we're going to do before we get to examples is this: leaving answers in terms of pi. There's several directions that will say leave your answers in terms of pi. It means you do not plug in the decimal approximation of pi. You're going to leave it in terms of pi, and I will show you the pi button on our calculators, because our calculators pretty much leaves things in terms of pi. It's kind of nice. And so our answer will usually contain pi in it when it's in terms of pi. So let's do some examples. This is number 6. I think I have 5 examples picked out for you. Let's see. H, J, I, and there's a little hat. That means we're looking for the arc. H, then J, then I. We're going this way. We're finding this. How many degrees is it? They gave us a 151. And this is missing on your worksheet, but it should be there. It should say JH is a diameter. If I don't know that, then I don't know that this is equal to 180 degrees on that half. So I'm going to put a 180 right there, just like that. I'm going to switch over to red. And so if I know that H, then J, then I is 180 plus 151, I can figure out what HJI is. 3, 3, 1, 13. Think that works? That's a review from the first section. Central angles are equal to their arc. 90 degrees, 90 degrees. If that's 90, this is a diameter, that's 90, and that's 90, or 180 and 151. That's what I'm doing. Pretty simple. Then the new stuff happens. The new stuff is like numbers 10 through 15. Number 11 says, what's the arc? Find the length of each darkened arc. We're looking for this distance, the crust of this pizza. Leave your answer in terms of pi. So if I want to know how long this is, it's a percentage of the circumference of the whole circle. This, when they give a number and it's right in the middle of a long line, they're telling you this is a diameter. I'm going to put a D next to it. If it's next to a radius, then it's a radius. You got to know the difference. So if I'm thinking about this, this is the arc. This is the diameter that goes through the center. Then I know that this half is 180, and this other half has to be 180 with that 30. That lets me know how many degrees this inside is. Like if that's 30 and that's a diameter and that's 180, then this has to be 150 degrees because that has to total 180. I just subtract. If I know that's 150, that's the measure of the arc that I say it's 150 out of 360 degrees. That's going to give me the percentage of the circumference. The circumference, I have two choices. I can either choose this one or this one, depending what they gave me. If they gave me R, I use this one. If they gave me D, I'll use this one. They gave me D. I'm going to use pi times the diameter or pi times 18. And this is what I'm going to plug into my calculator. And if you don't know how to plug into your calculator, I'm going to show you. Because these calculators have those fancy fraction buttons for you. The fraction button is the one, let me see if I can show you in this video, is the box over the box. I'm pointing at it right there. Which brings up the box over the box, 150. To get to the denominator, you press the down arrow. Now it's blinking in the denominator, 360. What am I doing? I'm multiplying times pi. Pi is right above the X10X button on the Casios. I see the little pi symbol. I have to press shift pi for it to show up. Times 18. And the beauty of these calculators is that it leaves it in fraction form and it leaves it in terms of pi as long as it's within a, let's say, less than 1,000. So in terms of pi, my answer is this. If I needed to, I can always switch it to a decimal. But remember, it said leave it in terms of pi, so this is the best answer. And if you don't have a calculator, here's what I do. I go, okay, let's see. Divide by 10, divide by 10. 18 goes into 36 two times. 15 over 2 pi. Sometimes you can do it by hand pretty quickly. So that's my answer, 15 over 2 pi. And that's a distance. Technically, that's in feet. Next example. Now they're asking us for area. They didn't give us any degrees, but they did give us this symbol, and I know how many degrees that symbol is. That is 90 degrees, which means the arc is the same. It is equal to it because it's a central angle. Central angles are equal to their arcs. Only inscribed angles and tangents are half. So now, because I'm finding area, I'm going to use a slightly different formula. How many degrees out of 360 gives me my percentage times pi times r squared. My radius here is 4. Now I can plug all that in my calculator. Or I can do it by hand. I'm going to show you what it looks like on my calculator. I love punching the whole thing on my calculator because then I can see, did I make a typo anywhere? I can double check that what I wrote down on paper and what I'm typing in is the same, and I press equals and I can get what the answer is. Technically, this is 4 pi units squared because we're talking about area. But if I wanted it, let's say I didn't have a calculator, 90 goes into 360. That's 1/4 of the whole circle. It's 1/4, right? I could do 4 times 4, and I can go 4 goes into 4 times 4, and there's the 4 pi if you wanted to do it by hand. Number 20. Number 20, they're going to try to trick you, but let's just see what we can do. I do not have the angle for the shaded area. I have to figure that out. Because they're putting the 10 next to the center, this means it's a diameter. Diameters have a total sum of 180 degrees, which means this diameter is 180 as well. Well, that's 72 and that's 180. I can subtract those two things to figure out what this angle is. And if you didn't know, it's 108 because 108 plus 72 is 180. That's your percentage, is 108 out of a total of 360 degrees. Since we're finding area, we use the area formula, pi times r squared. Now r squared, what is r here? They gave you a 10 trying to trick you. Can I use 10? No. You have to figure out what is the radius when they gave you the diameter. It's 5 squared. I'm going to type that whole thing into my calculator. 108 out of 360 times pi times 5 squared. (15/2 pi) is what the calculator gives me. That's the same thing as 7.5 pi. It told me to leave my answer in terms of pi, and technically this is in units squared. Hopefully it's not too hard for you. The last thing, there are like 3 or 4 word problems, and I can't show you how to do all the word problems, but what I can do is pick one and do one example for you. The last word problem I picked for you is number 24, and it says, the wheels on Reggie's bike have a 20-inch diameter. Here's the bike. Tire. That's the best. Oh, there you go. You get 6 spokes. And this distance is 20 inches, whereas the sister's bike has a bigger tire. We'll give her more spokes. It's a weird word, spokes. But that's what they're called. And the diameter of her bike is 26 inches long. The question says, to the nearest inch, how much farther does Reggie's sister's bike travel in one revolution than Reggie's bike? A revolution means one time around the whole circle. Well, I know what the distance on the outside is called. That is called circumference. There's Reggie's, and then there's the sister's. So what I'm going to do is I'm going to figure out what's the circumference for Reggie's bike, which is, I have 2 choices, 2 pi r or pi times d. That's a diameter. I'm going to use pi times d for Reggie's. And I'm going to use pi times this diameter for the sister. That means Reggie's bike travels 20 pi inches every revolution. And the sister's bike travels 26 pi inches every revolution. Now that may not make a lot of sense to you yet because those are in terms of pi. But the question says, how much farther does Reggie's sister's bike travel than Reggie's bike? We got to go and say, this is bigger than that. We're going to subtract these two things. And just to give you an idea of what that actually means, 26 pi is about 81.7 inches, whereas 20 pi is about 62.8 inches. And if I subtract those two things, it really means 18.8, which rounds to about 19 inches. That means that this bike, every time it goes around, it's going to go around 19 inches farther than the little tiny bike. Just so you know, that's our answer. That's where I'm going to stop your notes.